Hello again. This evening we're going to be speaking about electromagnetic and mechanical waves. What you'll learn: what does a wave carry? What are waves, or how are waves generated? What is the difference between a transverse wave and a longitudinal wave? And how do the particles in ocean waves move? But what is a wave? Well, the question then becomes let's talk about, to understand a wave, what does a wave carry? A wave is a disturbance that carries energy through matter or space. It carries energy because the wave has height, it has altitude, as we've talked about with waves, the amplitude. It's a disturbance because as it travels, it's going to make particles either move up and down or side to side. We'll talk more about that here in a very short bit. But a wave carries energy, and it's a disturbance. It causes, such as the guitar strings, it causes it to vibrate. It carries energy because it makes the guitar string move, so it transfers kinetic energy, you could say. A pipe, it causes it to vibrate, so it causes it to move. It must be transferring some type of energy that gets it to move. Energy in waves. Waves transfer energy, as we've said. Tsunamis carry enough energy to cause damage to coastal towns. We're going to talk about tsunamis and how they are waves and how they must be carrying energy to be able to do the work that they do. We've learned that for work to be done, it has to be some type of transfer of energy. And tsunamis do work. They move things, so they're doing some type of work when the waves come in. The energy of a normal ocean wave breaks up rocks into pieces of forms of sandy beaches. These rocks, over the years, have been battered and splashed and hit with these waves, and this energy is transferred and causing these rocks to break down. So waves transfer energy. Okay, let's talk about transverse and longitudinal waves. This is a new concept for us. What is the difference between a transverse wave and a longitudinal wave? Well, a transverse wave is a wave in which the particles of the medium move perpendicular to the direction of the wave that's traveling. And we're going to go real simple here, but a transverse wave is a wave that we all have used several times to talk about waves. All right, this is an example of a transverse wave. And we'll talk about why that's a transverse wave in a short bit. A longitudinal wave is a wave in which the particles of the medium vibrate parallel to the direction of the wave. A longitudinal wave would transfer more like this. And as you can see here, on the bottom here, we have where the waves are kind of close to each other. I had another one right there. Then the waves get farther apart and they become compressed again, spread out, compressed again, and spread out again. And this is what we call a longitudinal wave. I'm going to give you a hint. The transverse waves are, we're going to be talking about in great detail here pretty soon, over the next couple days. All right, let's talk about the wave motion versus the object motion. All right, and I've started to, well, I don't want to talk about electromagnetic here down here. I just realized I have that typed wrong. This down here should actually be saying transverse waves, which we're going to be getting into. Wave motion versus, we're going to be getting into electromagnetic waves, I'm sorry. These are transverse waves at the bottom we'll talk about here. Longitudinal waves are typically how sound travels. And a longitudinal wave, as I tried showing a little bit earlier, is going to have these spots where it's compressed and then where it becomes spread out. And if we had a particle, it's this wave. This right here is the wave part. It would be slowly traveling through or to the right. And if I had, let's say, a piece of tape on this item right here, so we put a piece of tape on here, right? This piece of tape would go to the right, it would come back, and then it would finish right where it was. But what I want you to see is that it's traveling parallel. Longitudinal waves, particles, are going to travel parallel. I'm not sure if I'm spelling that right, but the particles are going to transfer parallel. In a transverse wave, a transverse wave is really what we've been talking about, what we've been using, but it's not really a very good description of sound. Sound doesn't really travel like this, although we've used it because we understand it to be a wave. And now this is my wave traveling this direction. So the wave is traveling to the right, but if I were to put a piece of tape, let's say right here, as this wave continues, right, as this wave continues to travel to the right, and I'll just use these dotted lines right here, right, to show what would be happening here. Oh, I wanted red here, sorry. Let's try this again. I can make this a little better here with this red than what I did. You would be seeing that as this wave travels, all right, the red is maybe the second stage, the third would be maybe a third stage, but this piece of tape would be traveling up, and then once the wave actually got there, it would be clear here to the top. What would happen as this wave went by then? It would work its way back down. But what I want you to see here is that the piece of tape would be moving up and down, and this is what we call perpendicular, obviously. We'll have some greater examples, much better examples of this tomorrow in class. But the main thing here is a longitudinal wave is going to travel parallel, and a transverse wave, the particles are going to move perpendicular to the flow of the wave. My longitudinal wave is moving to the right. The particle moved left and right. It moved parallel. In a transverse wave, my wave is moving to the right, but the piece of tape moved up and down, so the particle moved perpendicular. Well, let's do a little bit more here. A transverse wave, even though we've really never called it a transverse wave, we know that it has crests, because we've used that terminology already. A crest is at the top, a trough is at the bottom. What we really need to talk here about is a longitudinal wave. And what we have here now are compressions. And what I want you to see is that compressions, all right, compressions correspond to crests. All right, compressions and crests. The other thing that we want to correspond to each other are rarefactions. A rarefaction is right here, which is what we call a trough. So compressions correspond to crests, and rarefactions correspond to troughs. But compression is where we have all of these waves that have been squeezed together, and a rarefaction is where we have the stretching out or the spreading of the wave. All right, waves and mediums. Most waves travel through a medium. A mechanical wave is a wave that requires a medium through which to travel. I've given you some examples of mechanical waves: sound waves and water waves. Another type of wave is an electromagnetic wave, a wave that does not require a medium through which to travel. Examples of this would be light waves, radio waves, and X-rays. Notice that up until this point, for the most part, everything we've been talking about in class has been a mechanical wave, because we've almost exclusively talked about sound waves. Now we're going to start heading into these electromagnetic waves, and light, radio waves, X-rays, all of these. The biggest difference, they do not require a medium. The ones we have been talking about, they do require a medium. So we're going from things that need air. Sound needs air. Sound needed to travel through water. It needed to travel through iron for it to travel. But electromagnetic waves do not. These are the waves that can travel in outer space. A mechanical wave would not travel in outer space. Alright, last slide. How are waves generated? Most waves are caused by vibrating objects. Well, let's talk about them again. An electromagnetic wave is caused by vibrating charged particles. A mechanical wave, the particles in the medium through which the wave passes vibrate. So in a mechanical wave, something that needs a medium, the particles in there could be the molecules, it could be the air, something is vibrating. When it comes to electromagnetic waves, it's the particles. And we're going to talk about these particles later on. They have a special term, and I'll go ahead and kind of bust the seal on that, and they are called photons. So later on we're going to talk about these photons and how they're vibrating. Well, hey, I hope this was informational. I'll see you on the flip side.